Guys, me, Sam McDonald. As you can see, I'm not in my same place where I'd always be. I'm actually in school this time. And all that stuff like multiple intelligence, Hurricane Igor, and also the climate change from last night and the one I'm doing right now called the Big Bang Theory. I learned from the best. Here he is.
Well, Sam, you're very generous in your compliments. I appreciate it. Now, Sam, as a scientist yourself, do you have any questions for me?
Yes. How did the Big Bang Theory actually start?
The Big Bang Theory?
Yes.
Well, according to most scientists, we think that the universe started at one single point in space and time called a singularity. And that singularity exploded. But it's very important to understand that it wasn't a traditional explosion or typical explosion. The explosion marked the beginning of space and time itself. So, in other words, the Big Bang didn't explode into space. And then the universe evolved from the radiation era, pure energy, the radiation condensed into or formed particles, kind of like the way water vapor condenses into water droplets.
Yeah.
Physics are very different, but that's the idea. And then those particles formed atoms, and we have the dark ages here when the atoms first formed, and then once they did, the light was able to get through. So after that, galaxies begin to form and stars and eventually planets. They go out 13.8 billion years. We have the universe the way it appears now. And we think the universe is about 30 to 40 billion light years in diameter. Contains perhaps up to 1 trillion galaxies, each galaxy containing up to several hundred billion stars.
All right.
It's a big place. And we think this is probably not the only universe. We think there may be numerous other universes, maybe an infinite number of universes. We just happen to inhabit this one.
Alright, so I would think, in my estimate, I would say there be 20 universes. Would that be accurate, or would be a lot more,
Well,
probably?
we think probably a lot more. I've heard numbers as high as 10 to the power of 540. That's based on the superstring theory, right?
Yeah.
And a superstring is the tiniest component of matter. So that would be 1 followed by 540 zeros. So it may be that in this infinite universe model, that there may be an infinite number of you living in those universes.
So you're saying that there's probably other versions of me in other universes?
That is the consensus, and these universes may be very different from ours. They have different laws of physics and chemistry. Matter may evolve very differently. They may not have very much matter. They may be much smaller, much larger. The thing is, we don't know, and we probably never will know. I think it would always be relegated to the realm of speculation.
Alright, so speculation and theorizing will probably go on forever for the other universes?
Well, we think our universe is undergoing accelerated expansion, and that is due in part to the dark energy, right, which composes about roughly about 75% of the universe.
All right.
So the universe is going this way. And will it reach a maximum size and then begin to collapse back in itself? And as it will in the closed universe will all just keep expanding, eventually undergoing what we call a heat death, many trillions of years in the future.
Alright, so is the solar system colder than the Earth or warmer? Or does it just depend on what
Well,
planet?
interstellar space,
Yeah.
between the ambient temperature of the universe, like between the stars and galaxies, on average is 2.7 degrees Kelvin, which is just a little bit above absolute zero.
So it's colder.
Temperature possible.
Alright. So another thing would be did the Big Bang Theory cause the volcanoes, earthquakes, tornadoes, tsunamis, and those other natural disasters to ever start happening?
Well, that happened, of course, after the planets form, right? And as the planet cools down, it's still very hot at the core. That can drive plate tectonics and volcanism and earthquakes. But also keep in mind that earthquakes and volcanoes and heat from the Earth's interior is made up of one of the 4 basic forces. We have strong nuclear that binds the atomic nucleus, the weak nuclear, which would make up the force that heats up the Earth's interior. In other words, atoms tend to decay and give off high-energy particles in time, and that we think combined with what we call gravitational accretion is heating up the Earth's interior. Then there's also gravity, of course,
Yeah.
and the electromagnetic force coming in the window right now from the sun.
Alright.
Also outside the hallway.
Alright, so also, do the tsunamis are caused by waves in the ocean, correct?
Well, an earthquake or even volcano can trigger a tsunami. The fact is, there was a tsunami watch in the Pacific Basin because of the earthquake in New Zealand, which was 7.8 on the Richter scale.
Alright, and with tornadoes, is that just wicked strong wind, or can something cause that to happen?
Well, tornadoes, once you have a planet with an atmosphere, a planet that rotates, that has differences in temperature, you can have weather. And in our case, the atmosphere is conducive to life. Organic chemistry is 21% oxygen, 78% nitrogen. And because of the forces in our atmosphere, due in part to the Earth's rotation and the difference in temperature between the equators and the poles, we have weather and sometimes extreme weather like tornadoes.
Alright, and there was one more thing that my fans want to know about the Big Bang. Is the weather coming from the universe, another planet, or is it just natural like those things that we just discussed?
Well, everything originates from the Big Bang. Everything that you see, including you, me, that camera you're holding, right? So, but you have to wait some time before a planet can form with an atmosphere to have weather.
Mm-hmm.
So, in that sense, everything, you can trace everything, every little event, when you're dropping my glasses on the desk here, to the Big Bang.
Would be gravity, right?
And that would be the gravitational force.
Alright, yeah, that's pretty much everything, right? For Big Bang?
Yes, Sam. So, right, gravity, right? And so why the glasses break? Well, because the electromagnetic forces that bond the atoms and molecules.
Yeah.
And then inside those atoms, we have the strong nuclear force.
Yeah.
Holding the atomic nucleus together. We hope there's not much weak nuclear force happening here because we can be contaminated by radiation and that can impact our health.
Alright, so yeah, guys, that's the person and all this stuff from that you've seen videos about science from. This has been me and my special guest. Nice to see you.
Hey, Sam. It's always a pleasure to do these great YouTube videos that you produce. It's an honor to be on your show. And I'm available anytime for a video. I kind of enjoy being on the air and promoting science education.
Alright, so see you guys in the next video. Hope you enjoyed it. Bye.